Thank you. Good morning. I'm here today to talk about a project that my company is currently developing, and that for the last 6 to 7 months, and that it focuses on the development of a decision support tool to support exploration activities for deep sea mining. Well, my company, it's IQSQ. It's a company that exists for more than 50 years, and that it focuses on engineering consultancy services to industry. This company is located on 16 locations worldwide, and the main business sectors that are comprised by aeronautical and aerospace industry, automotive, energy, and oil and gas. Currently, through its Sustainable Innovation Center unit, IQSQ is now pursuing new projects and new services based on Earth observation data. SAGRES is one of those projects, and its focus, as I said before, on the development of a decision-making tool to support ocean prospection and exploration activities targeting deep-sea mineral and also, in the future, biological resources. Our main market sector is the marine mining, or the so-called deep-sea mining sector. As an intermediate user, we are now starting to use Copernicus marine products to incorporate into our model. Currently, we are just using data from Cryosat-2 and GOES satellites. Our main end users are comprised by science and industry entities involved in ocean and ocean research and exploration activities, as well as national to international authorities involved in marine governance. Well, the main drivers for this service opportunity are the growing demand on raw materials for high-tech and low-carbon uses. It's expected to increase by 5% by 2020 and around 10% by 2030. Also, there is, it is known a huge potential on critical metal contents and economic value associated to deep-sea mineral resources. For instance, in the Pacific, in the Clarion Clipper zone, that zone has 3 times higher nickel, cobalt, and yttrium resources than on known global land-based mines. These metals are often used to make batteries and also cell phones and permanent magnets. Also, there is a lack of knowledge on the distribution and location of the deep-sea mineral resources, particularly within countries' economic exclusive zone. And more importantly, conventional methods for deep-sea exploration are very time-consuming, complex, risky, and costly. SAGRES application will consist on developing and validating an algorithm to support exploration activities based on satellite information and also complemented by in-situ and model data. It's our understanding that the fusion and analysis of all this data into a single source of analysis system can bring forward information that can be used as approximation vectors towards the resources in order to enhance the location and ranking of potential target areas, also to increase success rates, mission success rates, also to optimize missions times and reduce missions uncertainty and costs. This information also can be used to provide or to help us to provide some kind of environmental baseline information. Because deep sea minerals, economical viable deep sea minerals resources occur associated to specific settings in terms of geology, biology, and physical and chemical oceanography, we'll try to use and integrate the Copernicus marine products to feed our algorithm and enhance its forecast capability. So far, we have selected three products because they can give us information at a global to local area coverage, and also because they provide us data on current velocity, water temperature, water salinity, and also abundance of plankton, oxygen, and nutrients. Together, all these parameters can be used and worked as approximation vectors to what we want. However, because this is a challenging service opportunity, and because we are competing with very high resolution technology, we need products with high resolution grids. Okay. We need also data on parameters such as turbidity at several depth levels. Also, products related with paleoceanography. It is important also to have in-situ data at the bottom of the seafloor. This, for instance, can help us to module bottom currents, to try to predict where the resources may be, and also, more importantly, also high-resolution bathymetry data products. Well, the use of Copernicus marine products will greatly help us. Why? Because due to the huge data made available, the products should greatly enhance the algorithm forecast capability, okay? By integration and analysis of multiple parameters. Also, the parameters provided by Copernicus service will also contribute to provide credible and useful baseline information concerning potential environmental impacts related with the exploration activity to the end user. So, to conclude, through SAGRES Project, IQSQ is developing a decision support tool for smarter ocean exploration campaigns targeting deep sea mineral resources for science and industry, as well as to help and promote a more sustainable territory management for maritime governance authorities. The use of Copernicus marine products will help us to further develop our algorithm and also to provide more credible, precise, and useful information to end users. Our main benefits so far are by use of Copernicus products are the integration of multiple parameters and also the use of large volumes of data to better constrain the parameters correlations and help us to enhance the algorithm forecast capability.
Thank you.
Thank you.
Do you have any questions? Questions? Yes. I've got one. You didn't explain how you use the product, especially the biological ones.
Well, we are just starting because, and we are because some mineral resources occur associated to specific to specific settings where the marine biology is quite active. The abundance of living organisms are quite high. So we try to module that and integrate that into our algorithm. so that it can help us.
Hi. Okay. I didn't understand very well how you will use Copernicus data for that, because we know that marine resources are kilometers and kilometers depth.
Yeah.
And you say that you base your study or your research with several algorithms that are associated to environmental conditions, like organisms and fluids or something. And you have like kilometers of water above it, and you have dispersion and currents and waves.
Yeah.
And how do you will correlate the surface and the bottom?
Well, it will be difficult, but because some of the products that Copernicus delivers have some of the modules that Copernicus delivers have information about several depth levels. We will try to integrate that into our algorithms, but we are just starting to integrate this kind of information. This project is very young. As I said it before, we only use so far data from Cryosat 2 altimetry data, and from GOS it's gravimetry data. So we are starting to integrate and also to interpret that kind of information. Thank you.
In the catalog of CMEMS, we don't have only surface product. We have, as he said, we have product, in-situ product, and the modeling product are along the water column.
Yeah, also.